Okay, we're going to look at a couple problems that might appear on our first test, or similar problems nonetheless. So this first problem is obviously one where we can use our SOHCAHTOA. Obviously SOHCAHTOA is going to be used on a lot of these problems to define our big three ratios. And then we could find our other reciprocal ratios, as we know. So this says given tan is 5/6, find the value of the other 5 trigonometric functions. And it says assume the angle is in quadrant 3. So I have some angle in quadrant 3. I don't know what it is. Let's say it looks like this. Who knows? And it ends here. But we know the tangent is 5/6. Now knowing tangent is 5/6 means we know the opposite side and the adjacent side. The ratio is 5/6, just from our TOA. So the way we do this is we will make our reference triangle based on this with our reference angle in this corner. Very, very important to have it in that corner. So if you look at this, we know that this side is opposite, this side is obviously hypotenuse, and this is adjacent. Now the problem putting 5 here and 6 here for opposite and adjacent, if you think about in quadrant 3, the x and the y are both negative. So this is both -5 and -6. Which still doesn't violate our principle because -5 divided by -6 is still 5/6. So you have to always make sure you're looking for the signs on these triangles. So I can find the hypotenuse, -6 squared plus -5 squared equals c squared. Remember that we're always finding, hypotenuse always goes by itself. 36 and 25 is c squared. So that's 61 being c squared. So c is the square root of 61. So if I want to find the sine, cosine, and tangent of these, no problem. We already know tangent, but we can do it again. Why not? It's 5/6. Now, if the sine is going to be opposite over hypotenuse from our SOHCAHTOA, -5 over radical 61. And our cosine is adjacent over hypotenuse, -6 over radical 61. You could, of course, clean these up. This is -5 radical 61 over 61. This is -6 radical 61 over 61. But either way is fine. So quadrant 3, remember, only tangents should be positive, the others should be negative, and they are. Now we have to find the other three, cosecant, secant, and cotangent. I'm writing them in this order because they're reciprocals of the corresponding ones from above. So cosecant is the flip of sine, so negative radical 61 over 5. Secant is the flip of cosine, so negative radical 61 over 6. And cotan is the flip of tan, so 6/5. So whenever you see a problem like this where it gives you a ratio, very good idea to draw a triangle. Okay, let's go ahead and look at this one. It says, if the angle of elevation to the top of a building is 32 degrees, and you know the building is 100 feet away, how tall is the building? Okay. So we have a building, and we are 100 feet away from this building. And we know looking up, angle of elevation is an angle looking up is 32 degrees. We want to know how tall the building is. So hopefully you can see our triangle here, right? This is our right triangle. So it's a right triangle with the building being the opposite side, the 100 being the adjacent side, and the hypotenuse being the slanted side. Now, if I look at all these sides, the only one I really care about is I want the opposite and I have the adjacent. I don't really know the hypotenuse, and quite honestly, I don't really care. So opposite and adjacent is tangent. So I know tangent of the angle, I do know the angle in this case, is opposite over adjacent. So it looks something like this. So all I'll do was whatever's on the bottom we typically multiply by, so I'll multiply by 100. So x is going to equal 100 tan 32, and this is going to be in feet. So I would just put that in my calculator. Now make sure you're in degrees. That's really, really important, right? It has to be in degrees. So if you have your own calculator, make sure it's in degrees. So when I do that, I'm going to get x is approximately 62, I'm just going to go to the 10th, 62.5 feet, which seems reasonable for this building. Okay, so let's go look at the third problem. It says, which of the following would have to have the same value as sine of 300? So this is the first of many problems that kind of talk about the unit circle. So if I look at the unit circle on this one, it's a terrible unit circle, but you get the idea. 300, if I look at my unit circle, look at your paper, it says 300, it says 5 pi over 3, and then here you will see the point is 1/2 comma negative radical 3 over 2. Now remember, on the unit circle, this is always cosine and sine, so the sine of 300 is actually this radical 3 over 2. So if I want to look at which of these are the same, is the sine of 5 pi over 3 the same? And I would say it is. This is just the radian measure. It's just the radian measure of 300. Now cosine 300, if I look at the unit circle, cosine of 300 is 1/2, while the sine of 300 is negative radical 3 over 2. So that's certainly not the same. Now sine of 60 is an interesting one, so I'd have to look up here at 60 and look at the point at 60. So if I look at 60 on my unit circle, I get 1/2 comma radical 3 over 2. Now the problem with this one is sine of 60 is positive radical 3 over 2, because it's this number here. We have negative radical 3 over 2. So the sine of 60 is positive radical 3 over 2, so that's not the same. But if you look at the very next problem, it says negative sine of 60, so that one's good. Because I know the sine of 60 is radical 3 over 2, so if I put a negative sign in front of it, of course it's going to be the same as sine of 300. Sine of 660 is a big angle, so the question is, we know that big angles are coterminal, they have the same trig function. So the question is, if I subtract 360, do I get 300? And I do. So anytime you add or subtract 360, the trig value stays the same. So the sine of 660 is the same as sine 300. You can do a similar thing for negative 660. Obviously, it is really negative, so I'm going to start adding 360. So if I add 360 once, I'm going to get negative 300. So I'll have to add it again. So if I add it again, that is 60. Well, I know from earlier that the sine of 300 is not the same as sine of 60. So sine of negative 660 is sine of 60, but that's not the same as sine of 300. So this is a no. Okay, sine of negative 60, same idea. Let's add 360, and I get sine of 300. So obviously this one's okay. So you're either using your unit circle or you're adding and subtracting 360 to look at that idea of coterminal angles. So I would certainly expect to see a section on your test where there are things like that. Maybe they're true, false, something of that nature. So this page is all about unit circle. It says find the following any method you choose. So obviously I would look at this 1305 and know that's way too big, so I'm going to start subtracting 360. So if I do 1305 minus 360, I get 945. That's too big, so I'll subtract 360 again. And I get 585. That's too big. So I'll subtract 360 again, and I'll get 225. Which is fine, because that's on our unit circle. So the cosine of 1305 is the same as the cosine of 225. So if you look at your unit circle, which I'd obviously make sure you see, 225 is over here. The point is negative radical 2 over 2, comma negative radical 2 over 2. And as always, cosine comes first, sine comes second. It doesn't really matter here because they're the same. But it's the first one is our answer. It's negative radical 2 over 2. So the cosine of 1305 is negative radical 2 over 2. Same thing for the next one. It says find the exact value of any method you choose. So we've got 2 sine negative pi over 3 plus secant of 3 pi over 4. Lots of ways to do this problem. A lot of people would convert this to degrees. We know that pi over 3 is 60, so this is negative 60 plus secant. Now if I look, negative 3 pi over 4 is negative 135. You can convert that using, you can do the 180 over pi. I'm just looking at the unit circle and seeing it. Now I want to get these values from the unit circle, but they're both negative, so I'm going to add 360 to both. So that's 2 sine of 300 plus secant of 225. So we know these values, believe it or not, from things we've done on this review already. For example, sine of 300 is negative radical 3 over 2. That was on the previous page where we looked on the unit circle at 300, we looked at the y value, got negative radical 3 over 2. Now secant is the flip of cosine, so we're going to flip 225 is this point over here, so we're going to flip this one. So it's plus negative 2 over radical 2. We can clean this up a little bit. These cancel. This gives me negative radical 3. And if I rationalize this radical 2, I get 2 radical 2 over 2, which is just radical 2. So this is negative radical 3 minus radical 2. But again, found it in degrees, found things on the unit circle. These are ones we've obviously used in previous problems today, but that's the idea. So let's look at this last one. This last one talks about if this point is on the unit circle, find the 6 trig function values. Now I already said it's not on the nice unit circle we had in class. It's some other weird point, but we can still do it. So if you recall, we know that sine is the y coordinate, right? So this is sine, so it's just literally 4 radical 3 over 7. Even though it's not one of these nice points, you can still use a point given. The cosine would be the x, so that's negative 1 over 7. And the tangent, remember, tangent in the unit circle is y over x. Cosine is y, cosine is x, tan is y over x. So if I do y, 4 radical 3 over 7 over negative 1 over 7, 7's cancel and just yield me with negative 4 radical 3. You could also do 4 radical 3 over negative 1. Be a very similar kind of problem. Now once we have these from the unit circle, we can find our other ones by doing the reciprocal. We just have to remember that cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So this becomes 7 4 radical 3. This becomes negative 7. And this becomes negative 1 over 4 radical 3. Now if you wanted to, we could certainly rationalize it. We could multiply top and bottom by root 3. We get 7 root 3 over 12, because 4 times 3 is 12. Don't have to rationalize it for secant. And same thing for multiply top and bottom by radical 3, negative radical 3 over 12. So even though I don't really know this point, it's just some weird point on the unit circle, knowing that sine is y, cosine is x, tan is y over x, I can certainly find all my values. Can I multiply? Okay, let's look at number 6, which talks about the graph of this. So we're really, like we said in class, we're really focused on the period, the amplitude, the phase shift, and vertical shift. So the first thing we're going to have to make sure, we have to make sure that we have the number in front of x factored out. So if I look at this, I have a 2x minus pi. So what I'm going to make sure I do is I'm going to factor that 2 out and be left with x minus pi over 2. So all I'm going to do is when I factor that 2 out, I'm just going to divide the number that was in our parentheses. That's how we factor out a number and leave a fraction. So why this is important is this is our A, this is our B, and this is our C. We have no D, we have no vertical shift, which is okay. So amplitude, remember, is the absolute value of A. So in this problem, it's just 3 over 2. The period is simply going to be 2 pi over B. So in this case, it's 2 pi over 2, which is just pi. Our phase shift, or horizontal shift, whatever you want to think of it as, is just C. So that's going to be pi over 2. Remember, if it's negative, it's a positive shift. If it's positive, it's a negative shift. And there is no vertical shift because there's no D at the end. It would normally be D, but there's none. Okay? So you could certainly graph it. We could look on Desmos and see some points. We could graph it ourselves. We know the graph is going to start at positive pi over 2. So this one looks like it's in increments of pi over 12. So that would be 6 of those. So here would be pi over 2. And I know it ends in 1 period, so that would be, if I add 1 pi to that, I would get 3 pi over 2, which is between 4 pi over 2 and 3 pi. Now again, we're not super stressed about this. We can try to find the middle. We know this is the middle, and this point, and this point. We know the amplitude is 3/2, so our graph would simply start here because it's sine. It would go up to the maximum, which is 1.5 here, back to the min, or to the middle, to the min, and then here. So it would look something like this. You can certainly look on Desmos, and for this, the big thing I'm looking for is the parts of the graph over here. I'm not even sure I'll put a graph on the test, to be quite honest with you. All right, so jumping back to the first section we did with the first quiz material, we have sector area and arc length. So if you remember, sector area is 1/2 r squared theta, and arc length is r theta. But the key thing for both of these, theta had to be in radians. So in this problem it says, given a sector area cut out of a circle has a central angle of 40 degrees and a radius of 5. Find these things. So the first thing I'm going to have to do is I'm going to have to turn 40 into radians. So I'm going to multiply by pi over 180. That's going to give me 40 over 180 pi. Cancel the zeros, so that turns into 2/9 pi. So now I'll just plug things into my formula. So for example, the area is 1/2 r squared times theta. And the sector area would simply be the radius times the angle. Now I would round these. Let's just round to the nearest tenth. So when I put this in the calculator, this first one is going to give me 8.7. But double check that, of course, and 8.7, and that would be in square yards, so that's still pretty big. And then 5 times 2 pi over 9 is yielding 3.5, and that would just be in yards. So area is always squared, and arc length is always linear, so only first degree. Okay, let's look at number 8. If a ball is spinning at a rate of 25 revolutions per feet away from your body, find the angular speed in radians and the linear speed in miles per hour. So this is the problems where we had linear or angular speed, theta over t, and linear speed of r theta over t. All these formulas will be provided for you on the test, so no need to worry about memorizing arc length, area, angular speed, and linear speed. Now our angle, it says 25 revolutions per minute, so that's 25 times 2 pi, because it's 25 full turns. You might as well keep it in radians. The time is 1 minute, and our radius is 2 feet away from our body. So let's start with angular speed. So angular speed is simply the angle, which is 50 pi, divided by 1 minute. Now this is in radians, and we want our angle, our thing in radians per second. So we have radians, but we don't have seconds. But we do know that 1 minute has 60 seconds in it. So in our conversion, we just have 50 pi divided by 60, which is 2.6. If I'm going nearest 10th, 2.6, and that would now be in radians per second. Let's go ahead and do linear speed as well. So linear speed is going to be r, which is 2, times theta, which is 50 pi, over 1 minute. Now, I know this is in feet on the top because the radius was in feet. So we have feet per minute, we want miles per hour. So we got some converting to do, right? Well, I know there are 5,280 feet in 1 mile. So now I'm in miles per minute. And then I'll just simply have to convert to hours. So there are 60 minutes in 1 hour. So now I'll simply multiply the things on the top and divide what's on the bottom. So 2 times 50 pi times 60 divided by 5280. So I get 3.6 miles per hour, which doesn't seem unreasonable since we're spinning a ball around some circular path. It's D. Okay, let's look at these last couple problems. They're very similar to ones we've done. These really don't have a ton of new problems to it. So 9 says, always good to do extra practice though. 9 says, given the angle theta in quadrant 4, so we have an angle in quadrant 4. Who knows how it gets there? Let's say it gets this way. And tan is -3. So if I think of this triangle, I'm going to make my reference triangle with my reference angle in the corner. Gives me tan is -3, or -3/1. Now from SOHCAHTOA, I know this is opposite over adjacent. Now the negative can go on either one, but in this case, I would definitely say the -3 is going this direction and the adjacent is here. This is opposite, this is adjacent, and this is hypotenuse over here. So 1 squared plus -3 squared equals c squared. That's 10 equals c squared because it's 9 plus 1. So c is square root of 10. So our hypotenuse is square root of 10. So, same old stuff. So sine of theta is opposite over hypotenuse, -3 over radical 10. Cosine is adjacent over hypotenuse, 1 over radical 10. Tan we already knew, tan was -3. And then we just start flipping. Cosecant is radical 10 over 3 negative. Secant is just radical 10 over 1. And then cotan is the flip of -3, so -1/3. So we've had 2 examples of problems like this where you're having a ratio and having to find the other one. So I would certainly be expecting something like that to be on your exam. Number 10 says, find the reference angle and one angle coterminal to it. Okay, so -120, I know is going to go this direction. So we went backwards 90, and then we went backwards a little more. So our reference angle is going to be the angle between this final ray and the x-axis. It's always the acute angle and the x-axis. So it's negative 120. If I would have went fully a half circle back, that would have been 180. So I think we can agree that there is 60 degrees left to go. Now, it would be negative, but remember, reference angles is just this angle. It doesn't really necessarily take in a direction. So the reference angle is simply just 60. The coterminal part is very simple. You could just add or subtract 360. I feel like we've done that a lot. So if I take 120 and add it to 120, I get 240. So essentially that would be this angle going this way. So it ends up in the same place, it just takes a different route to get it. So just in general, things I've seen a lot on this thing, if we don't like the angle, we can always add and subtract 360 to it. That's a pretty powerful tool. Or 2 pi if you're in radians. Okay, these last ones are, again, we're back to unit circle. You've seen a lot of these problems are unit circle or formulas for radians or some of the graph stuff, so nothing crazy. So if we look at these, we have what are the following? Cosine 5 pi over 6. Is that on my unit circle? It is. 5 pi over 6 is over here. It's negative radical 3 over 2, 1/2. Remember, cosine is x, sine is y. I can't say that enough. So cosine is negative radical 3 over 2. Now sine 690 is not on my unit circle, so I'm going to subtract 360, and I'll get sine of 330 is the same as sine of 690. Now if I look at 330 is over here. So my point on the unit circle is radical 3 over 2, comma, negative half. Well, remember, cosine is x, sine is y. So in our case, the sine of 330 is negative half, so the sine of 690 is negative half. Last one is 3 pi over 4, which again is on our unit circle. If I look at 3 pi over 4, it's over here in quadrant 3. Nope, that's not right. It's in quadrant 2. So 3 pi over 4 gives me negative radical 2 over 2, comma, radical 2 over 2. So sine is y, cosine is x, tan is y over x. So it's radical 2 over 2 over negative radical 2 over 2. Cancel the 2's, cancel the radical 2's. This is simply just negative 1. So there were a lot of problems on this review, and obviously you'll have time in class to ask questions about it, but your test will certainly not be quite as lengthy as this review, but I always think it's a good idea to have as much practice as we can when getting ready for these tests. So obviously go through this review, make sure you're asking good questions, and we can answer those questions next week.